Good afternoon, everyone. As mentioned, my name is Jeff Sindelar. I'm an associate professor and extension meat specialist at the University of Wisconsin-Madison. And for those of you who have no clue what an extension meat specialist is, first you have to understand that I'm a meat scientist by training. And I can prove this if necessary. I have a diploma in my office that says Doctor of Philosophy in Meat Science. This is true. The backside of that story, I'm a faculty member at the University of Wisconsin-Madison, part of the Department of Animal Sciences, and I work in the Meat Science and Muscle Biology Laboratory. And as part of my position, about 80% according to my job description on paper, I am to provide assistance to the meat industry, meat and poultry industry as that is, youth, consumers, and anyone interested or needing unbiased scientific information about meat science, poultry science, or food safety. The other portion of my position is doing research in those areas, and I primarily am interested in working more of an applied research program. Before I get into my slides, I want to make a very special announcement. Dr. Mike Doyle, who we have just heard from, just hot off the press, as of about 4:30 p.m. Central Time yesterday, was awarded one of 2 Distinguished Alumni Awards at the University of Wisconsin-Madison. Dr. Doyle, congratulations. Very well received. For those of you that do not know Dr. Doyle, and I suggest I believe everyone probably does very well. Dr. Doyle is before his career at the University of Georgia, has spent some time at the University of Wisconsin-Madison, was involved with the Food Research Institute on campus, heavily involved, received all his degrees from the University of Wisconsin-Madison. So it's really fitting and exciting that I have a chance to speak, and of course in front of you, Dr. Doyle. Perfect. So, I'm an extension guy, so I know how to adjust. Okay, so my conversation is, or my discussion is talking about the role of sodium chloride in processed meats. And I want to take a little bit of a different approach to this. So, first and foremost, sodium chloride is important for safety. But right behind that, sodium chloride for processed meats is important for quality. And as we have learned and have had a lot of comments so far today, important for consumer acceptance. So it's important, in my opinion, not to separate those in this conversation, this context, because safety, quality, and consumer acceptability are really tied together. Before everyone is ready to crucify me for saying that, bear in mind the history of sodium chloride use in processed meats. Before refrigeration, we used it for preservation, very high concentrations. And over time, that, of course, has changed. We have refined products. We have lowered the concentration or the added amount of sodium chloride in processed meats because it's not needed for preservation. However, we still preserve some of those preservation qualities. So we have, and when I say we, I'm referring eloquently to the meat and poultry industry, have over time reduced sodium chloride in processed meats. And if this conversation were occurring 15, 20 years ago, there would be a lot more opportunity to have reduction in salt for these products. So we're going to cover talking about processing requirements for sodium chloride, very important, food safety importance of sodium chloride, shelf life implications of reducing and removing sodium chloride, as well as wrapping things up with sodium chloride reduction approaches, considerations, and obstacles. Salt has critical functions. Clearly, in processed meats, those critical functions includes product identity. Part of the reason that processed meats are what they are is because of the inclusion of sodium chloride. You cannot manufacture a Frankfurter without using the correct amount of sodium chloride. And we will see that sometimes that can be a little bit challenging when we delve into sodium reduction conversations. Sodium chloride is important for preservation, not as near as important as it was years ago, but absolutely today it still is important. And we utilize, of course, sodium chloride for safety. In addition to those critical functions, salt is important for flavor, texture, and juiciness. Did anyone have a aha moment like that was a surprise? So, not to par down on any specific products, because it's a really, really difficult thing to do, I want to take a little bit more of a holistic approach, which is not easy for a scientist, but really to kind of help us navigate through this conversation. So if you look at the source of sodium in processed meats, and we have seen this in a couple different presentations already, we see sodium coming from a number of ingredients, common ingredients. For sure, sodium chloride. We use a lot of sodium lactate and other sodium-based antimicrobials. Sodium phosphates are commonly used in processed meats, and sodium diacetate is another one. All those ingredients have varying levels or concentrations of addition. We can see salt being used between 1.25 and 2.75%. In some products, that number is higher. Does anyone consume a country-cured ham or prosciutto or any type of copa, capicola? You are consuming more than 2.75% salt in that product. And that is partly because it's a regulatory requirement. That product, by USDA definition, standard of identity, must have at least 4% salt in the finished product. But we add these ingredients for different purposes, whether it be moisture management or providing texture, safety, flavor, a lot of different reasons. The take-home from this slide is that it's not a one-size-fits-all situation. We don't add sodium lactate to all products. We don't add sodium phosphates to all products. And we add some of these ingredients at higher concentrations for others. If we look specifically, and here's a few examples of some different processed meats. So here's an example of a John Morrell beef frank, or wiener, I saw the word, a couple talks ago. Franks are from the origin of Frankfurt, Germany. Wieners are of course from the origin in Austria, used synonymously. But if we look at the concentration or the contribution of sodium from these all beef Frankfurters, this John Morrell product, and it's a little bit difficult to read, and I apologize for that. That product per serving is about 420 milligrams. Here's another example of a different Frankfurter. That contribution is around 650 milligrams. So in this case, according to this nutritional information, about 27% of your percent daily allowance for sodium, and this is in context with the 57-gram Frankfurter, which is about normal or an average size for a Frankfurter. A lot of sodium, a lot of salt. How about another product which we're very which we're all very, very knowledgeable about from a consumption standpoint, hams. So if you look at the nutritional deck for this product, we scroll down to sodium, we see that number is a little bit lower, 400 milligrams per 56-gram serving, which equates in this case to 17%. And yet another product, which many of us might think this is the highest sodium product, but it's actually not the case. It's quite the opposite. 2 slices, so 14 grams. Of course, if you scaled it up to the other consumption amounts, 56 grams, this would not be the case, but 2 slices. Okay, this isn't a realistic number. No one eats only 2 slices of bacon. I get that. But this is what's on the label. 260 milligrams of sodium. So, we see 3 different products, 3 of hundreds of processed meat products on the marketplace. These 3 all have very different sodium content, all different salt addition levels. And that's primarily because of the functionality of salt. Each one of those products has a different reason for the salt addition. The Frankfurters being an emulsion, the ham being a whole muscle product where bigger pieces of muscle are glued back together, and bacon, where we're looking primarily for flavor and also for a little bit of protein solubilization to give that firmer texture. Bacon is a cooked version of salt pork. Those two products are very different. Salt is the primary reason for that. So let's talk a little bit about a little bit deeper regarding the topic of the quality of the quality impact or the quality importance of salt in these products. So as I've mentioned, and it has been discussed throughout the day, salt is important for solubilizing, swelling proteins, increasing water holding capacity. We like to use the term managing moisture, because that is in fact what we are doing. Either moisture that's in a product, in a meat matrix, or water or moisture that we are adding. Important for stabilizing fat. In case of emulsions, is very critical. Important for flavor. Some older research has shown that consumers can start significantly telling the difference or noticeably telling the difference in products that are salty versus not salty around that 1.8 to 2.0% addition level. And that is just a very, very general comment. But there are thresholds, of course, as we know, to what consumers detect as being salty versus not salty. And salt is important for cured color development and absolutely for the control of spoilage bacteria. Looking even a little closer at this salt solubilization, this texture contribution, this moisture management contribution, we're really focusing on the effects that we receive from localizing myosin and actin, the two primary contractile proteins, which of course then we can manipulate through the solubilization, the unfolding in a controlled sense with salt, the inclusion of heat and other mechanical actions to create the texture, which is what makes processed meats what they are. This is, of course, a dose-dependent situation. So this figure shows a concentration of salt in relationship to myosin, one of the two contractile proteins, and the percent solubilization, so the opening of the proteins. And we see this very critical zone of around 1.5 to 1.6% salt concentration where we start to see significant protein solubilization. Less than that, we have solubilization problems, we have binding issues, we have texture problems, we have moisture management problems. And above that, of course, is where we receive the true benefit of sodium reduction, of salt inclusion. From an emulsion standpoint, we must solubilize protein, and that is depicted by these little squiggly lines, and surround and encapsulate the fat to stabilize that fat. The protein which has been solubilized also forms alliances with other protein to create a strong meat matrix. The equation for successfully creating a meat emulsion, or really a meat matrix. And the addition of salt is absolutely critical for moisture management, for moisture control. This is a pH-dependent phenomenon. So the x-axis shows the pH of meat. This dip in the inverse bell-shaped curve shows the isoelectric point of meat. The number of positive and negative charges equals 0. As we move away, as the pH moves away from the isoelectric point, we see an increase in water holding capacity, increase in moisture management, and this phenomenon is increased when salt is added to the meat system. And just very generally, to kind of finalize the comments about moisture management, a very simple study that was done several years ago looked at water binding or water holding capacity of a meat product, looked at different levels of salt, cooked those products, measured the moisture loss, and you can see once we start getting close to where we're in that myosin solubility zone, that 1.5%, 1.6%, we start to see very significant, very drastic moisture loss, cook loss. And this is where we are at, where the meat and poultry industry is at in terms of where the current salt concentrations are. So we are getting close to being at about the lowest level that we can be. We use other ingredients synergistically. So sodium phosphates, which have been introduced, act synergistically with salt to enhance the effectiveness of salt. This is one way that we can have lower levels of salt and increase functionality of that salt. So this graph shows a pH effect with the water holding capacity value, salted meat alone, salted 2% salt plus a little bit of pyrophosphate, a little bit of diphosphate, and you get a synergistic increased response, allowing the overall salt levels to be a little bit lower. Moving on to safety, and as I mentioned in my introductory comments, these really are very closely connected because of the state of where salt levels are currently at in the meat and poultry industry. We've heard discussion about control of microflora, control of pathogenic bacteria. Salt has also been shown through research to have synergistic effects with nitrite. And it's been suggested in some studies that for every 1% of salt that's added to a formulation, that equivalates to about another 50 parts per million nitrite. Nitrite, which is not a topic of this discussion, is very, very, very important for food safety purposes. So these are the three primary factors that affect the salt or the salt and food safety relationship. The type of product. As I've mentioned, all products are different. All products need salt for different reasons. That's not only true for quality, but also for safety, and as we'll see, it's also true for spoilage. Understanding what the current salt level is and determining what is the potential for reducing salt to achieve sodium reduction, and realizing that much research that has been done has likely been done at current or higher salt concentrations. So as we move lower in salt levels, the number of studies that can support food safety decisions are fairly scarce. And then there are other factors that we have to consider, such as water activity or moisture content, inclusion of sodium nitrite, which I mentioned a minute ago, inclusion, type, and level of antimicrobial, packaging systems, pH, target pathogens, et cetera, et cetera. We know, and these figures are all predictive models generated through Combase. We know that salt has this effect as this is shown by generation time, parts per million lactate, such as from an antimicrobial. As the concentration of salt increases, the generation time also increases. We can apply this model to a meat product, and we can apply it to different meat products and have different outcomes. So this is generally what we see, but it's not always what we see if we're comparing hot dogs, hams, bacon, and other products. And if we look further into pathogenic bacteria, as salt increases, generation time typically also increases until we are dealing with some of the salt-tolerant strains such as Staph aureus. So moving in from quality to safety now to shelf life, salt is important for shelf life. In most products, that is the case. In some products, the level of salt that we have in products really don't affect the shelf life significantly more. There's actually other technologies that have a bigger impact than the salt concentration. But regardless, salt is still part of the shelf life equation. Inhibits spoilage bacteria, primarily through reducing water activity. And shelf life beyond salt, or the addition of salt, is dependent on a lot of other things, such as raw material quality, microbiological quality, so the amount of the incoming load of spoilage bacteria, sanitation practices in meat and poultry operations, GMPs, and then some of these other aspects, antimicrobials, the lethality processes, and also, and for sure, post-processing conditions. And another predictive model to illustrate this, of course, in general terms, looking at a Combase predictor model, as salt levels increase, our generation time of spoilage bacteria also increase. So some of the overall challenges, kind of pulling all these three themes together, safety, quality, and spoilage, is there are no universal methods or ingredients to aid in sodium reduction. Each product type is its own condition. Because of this, there's no common solution. So it makes it difficult to cut sodium across the board for all processed meat products, because some may suffer for quality, some may suffer for safety, some may suffer for shelf life, and others may suffer in all three. So each product must be looked at specifically at its specific attributes. Emulsified products, which are high fat, low moisture, cured, ground products, which could be fresh or which could be cured, could be uncured, could have antimicrobials added, may not, and whole muscle products, which fall under the same auspice. The food safety intervention or interventions that are used also come into play, and you know, science can tell us a lot of things, but there still is a cost of doing business. So in some cases, sodium reduction technologies are cost prohibitive, and in certain cases, completely inhibitive of some of these technologies. So, two approaches which are occurring in the meat and poultry industry for sodium reduction. The first is to simply reduce salt. And we've seen a number of large operations, you know, Smithfield being one of those that have announced and have taken long-term salt reduction approaches, slowly reducing salt over time, and during that period of time looking at different interventions, allowing them enough time to look at different products and processes. And in some cases, that approach is very effective and it has no or very minimal impacts or effects on quality, safety, or shelf life. However, in some cases, quality and safety needs additional compensation or help because of a reduction system. The second approach has been the replacement approach, which is of course more expensive and can be more technically challenging. Potassium chloride is by far the most common system used, as well as newer systems incorporating potassium chloride and other ingredients such as bitter blockers or masking agents. And we also have seen a lot of growth in salt enhancement systems. So, how much reduction is possible? And how much reduction should and can take place with processed meats? It depends. The great question. It depends on the type of product, the current salt concentration used, the safety or the risk of that particular product. You know, is salt reduction in bacon the same safety risk as salt reduction in a high moisture, uncured product like a deli style turkey breast? Maybe, maybe not. The need for functionality of the salt, why we started using it in the first place, and the availability for replacement ingredients or replacement systems which can allow that reduction to occur. So some concluding thoughts. How low can we go? It depends, of course, on the impact of quality as well as the impact on safety. And there is certainly a host of research that needs to take place to really understand the safety side, to determine what is the efficacy of sodium reduction and what impacts does that have on safety as well as the quality and shelf life. Questions?
We'll have time for one question and then we'll address the rest at the round table. Any questions?